In this video, I'm going to be working through Review 10, which is a multiple choice, no calculator review. Okay, so the first problem is talking about if f of x is cosine squared of 3x minus 5, okay, so cosine squared 3x minus 5. Then f prime of x is equal to what? Okay, well, that's going to be cosine of 3x minus 5 and then squared. So this is a chain rule question. So I'm going to start with the outside power rule. 2 times that thing to the first power times its derivative. So 2 times leaves the inside the same. Multiplied by the derivative of the inside. The derivative of cosine is negative sine. Leave the inside the same. And then multiply by the derivative of the inside. And the derivative of 3x minus 5 is going to just be 3. So I'm going to have negative 6 cosine and sine. So that's answer choice D. Second one, this is the antiderivative of 1 over t times the square root of t dt. What we're going to want to do, we're going to want to rewrite this as a power of t. So this is 1 power, this is half a power. This is in total 1.5 powers in the denominator. So it's going to be negative 1.5 power of t. Okay, so I'm going to increase the power by 1. And divide by the new power. So if I'm dividing by negative 1/2, that's basically multiplying by negative 2. And there's going to be a plus c because it's an antiderivative. So that is negative 1/2 power. There's only one of those answer choices, and that's answer choice A. So on right, f is 5 minus x over 3, or x to the 3 plus 2. All right, and then we want the derivative, so we're going to use the quotient rule. Bottom, derivative of top, minus top, derivative of bottom, divided by the bottom squared. Okay. That's going to be, all right, so it looks like I'm going to have to distribute this, and yeah, I just need to go all the way. I can't really do anything clever to eliminate answer choices, so I'm going to have a negative x to the 3 minus 2, and then I'm going to actually distribute this first and then subtract it, so I'll have 15x squared and negative 3x to the 3rd. Okay, so I've got negative 1x to the 3rd, and then I'm going to add 3x to the 3rd, so I'll have 2x to the 3rd, positive 2x to the 3rds. And that's answer choice C. All right. The position of a particle moving in the xy plane has, okay, so the position vector is 4t to the 3rd and y of 2t. That's interesting. Oh, I think I've seen this problem before. Where y is a twice differentiable function of t. At time t equals 1/2, what is the acceleration vector of the particle? All right, well, v of t, you take the derivative of s. And we can take the derivative of a vector-valued function by taking the derivative of each of its components. So that'll be 12t squared, and y prime of 2t multiplied by 2. Okay. V is v prime of t, and let's do it again, 6t, and, well, y double prime of 2t times 2, constant multiple, I don't need to do the product rule, times 2 again for the chain rule. So a of 1/2 is going to be 3 and y double prime of 1 times 4. And that was answer choice A. Okay, let's talk about strategy for just a second. Suppose you just did not understand what they were getting at here. You just don't know, you don't get it. That does not need to keep you from getting this problem right, because there are 20 squared. Wait, hold on. No, this is not it. It's going to be 24t. Yeah. Okay, I almost... Oh, and A wouldn't have even been right because it didn't have the right second component. Oh man, that was very silly. All right, so this is going to be 24t. Yeah, 12 times 2 is 24, not 6. So, and then 24 times a half is 12. So we have it down to 2 answer choices based on the first component. And it's answer choice D because of the chain rule twice. All right. Number 5, hold on just a second. All right, number 5 is a geometric series problem. So we are looking at the sum from 0 to infinity of negative e over pi to the k. All right, so first things first, we need to decide, is this going to actually converge or not? We need that ratio, that number that's getting taken to the kth power or the nth power or whatever, we need that to be between -1 and 1. But since pi is bigger than e, pi is bigger than 3, and e is less than 3, that means this fraction is going to be between -1 and 1, and the series will converge. So the sum is equal to the first term times 1 over 1 minus r. All right, well, we just need to figure out what is the first term. I'm going to say that the first term is where k equals 0. Negative e over pi to the 0 is going to be 1. And then 1 over 1 minus the common ratio is negative e over pi, so it would be plus e divided by pi. Now, this is going to require a little bit of arithmetic here, right? I'm going to have to go in and I'm going to have to say, well, 1 is going to be pi over pi. So I could combine this to be like, well, in the denominator, I'll have a pi plus e over pi. 1 over a fraction effectively flips the fraction, so I'll have pi over pi plus e. That is answer choice C. All right. Let's see. Can I just move that up a little bit? Okay, number 6 is basically that's pretty much the situation. Which of the following is true? Okay, answer choice A is that the derivative, it's a limit that's equivalent to the derivative. The limit as h approaches 0. Basically, it's saying f prime of A exists. F prime of A, f is not continuous at A. There's not like a tangent that we can put on that point, and there's nothing to put it on there, so okay, not differentiable. The limit as x approaches A of f of, as x approaches A from the positive side of f is not the same as the limit as x approaches A from the right of f of x. That's not true. It is the same. The limit exists. It's just not equal to the value of the function. And that's answer choice C. The limit of f as x approaches A is not equal to f of A. That is true. Okay, so that's going to be the right answer. And then the limit as x approaches A of fx does not exist. No, that would be if these two things were going, these two pieces were going to some different y values, right? Okay, so let's move on to number 7. It looks like we have some good integral property questions here. Okay, how much further? Okay, there we go. If 4 to -10, so that's -10 to 4. I'm going to write everything forwards, just so I don't get confused. G of x dx is equal to positive 3. And the integral from 4 to 6 of, that's g, is equal to 5. Then, really? Is it that easy? Okay, well, they're going to say, okay, we've got -10 here, we've got 4 here, and we've got 6 over here. And, just assume it's like that. What they're saying is that this has got to be +3, and this has got to be +5. I'm clearly not drawn to scale, but they want the integral from -10 to 6, so that's just going to be 8. It doesn't seem too good to be true. Okay, number 8. The length of the curve y equals sine 3x. All right. Well, if y is a function of x, then we have a formula for the arc length of just a y equals f of x type function. That length is going to be equal to the integral from x1 to x2 of the square root of 1 plus dy dx squared dx. And that's one of those things that you know. And if you don't know yet, you need to start knowing very soon. Okay. Dy dx is equal to 3 cosine of 3x. And so this length is going to be, I'm going to have to square this, and so it's going to be from 0 to pi over 6, square root of 1 plus, square this, I'll get 9 cosine squared 3x. And that would be answer choice D. Okay, number 9. The slope of the line tangent to the graph of y equals x e to the x. So the derivative, I'm going to have to use the product rule. Take the derivative of x first, leave e to the x the same. And then add in, leaving x the same, taking the derivative of e to the x. But the derivative of e to the x is just e to the x, so I'm just going to leave it the same. At x equals log of 2, the slope of the tangent line, that's y prime. So log 2 is going to be e to the log 2, that's 2, plus log 2 e to the log 2. All right, so that's 2 plus log of 2 times 2 is 2 more log 2's. And that's answer choice B. All right. Number 10, here we've got a little bit of Euler's method, and oh man, looks like it's going to come back with some unpleasant fractions, but that'll be all right. We can deal with that. Okay, y prime equals x minus y. F of 2 equals, I'm going to have to scroll a little bit. It's not, f of 2 is 8. So I want to find f of 3, or an approximation for f of 3, using 2 steps, equal size. So I'm going to go from 2 to 3. My first step will be 2.5. My second step will be at 3. So my first slope, or I guess I'll start with a point. That's 2, 8. The slope corresponding to that is x minus y is -6. The equation is y minus 8 equals -6 times x minus 2. My approximation is going to be when I plug in x equals 2.5. So I'll have y is approximately equal to 8 plus -6, minus 6, positive 8 minus 6 times 2.5 minus 2 is 0.5. So 8 minus 3 is 5. And my new point is 2.5 and 5. Okay, that's the first step of Euler's method. My second step, I'm going to just do the exact same thing again. My new point is 2.5 and 5. The slope corresponding to that would be 2.5 minus 5 is -2.5. So my equation, still don't have enough room, is y minus 5 is -2.5 times x minus 2.5. So my approximation is f of 3 is going to be approximately equal to 5 minus 2.5 times 3 minus 2.5 is 0.5. Again, always important that these are the same number, provided that it's 2 steps of equal length. And, well, half of 2.5 is 1 1/4. If I had $5 and I lost $1.25, I'd have $3.75 left. So I need to just figure out which of these is $3.75. I think that's going to be 15 over 4. Yeah, because 16 over 4 would be 4. Oh, whoops. All right, here we've got a nice implicit derivative. X squared plus xy minus 3y equals 3. And we want the value of dy dx at the point where x is 2 and y is 1. So 2x plus y plus x dy dx minus 3 dy dx equals 0, right? Taking the derivative with respect to x, and this is going to require a product rule consideration, and the derivative of y with respect to x is dy dx. Okay. So when x is 2 and y is 1, I've got 4 plus 1 plus 2 dy dx minus 3 dy dx is equal to 0. So I've got 5 minus dy dx equals 0, so dy dx has to equal 5. And that's answer choice A. Okay, number 12. I'm seeing a integral of a fraction. So I'm already thinking possibly partial fractions. I'm looking at the answer choices. I'm saying the denominator is factorable. I'm saying this is definitely partial fractions. And 3x plus 1. All right. Yeah, I can see that this is x minus 3x minus 1. So 3x plus 1 divided by x minus 3x minus 1 is going to be equal to some number divided by x minus 3 plus some other x minus 1. All right, now I'm going to multiply both sides of this equation by x minus 3 and x minus 1. So I have 3x plus 1 equals a times x minus 1 plus b times x minus 3. Okay, I'm going to let x equal 1 so I can figure out what b is. So 3 plus 1 is 4 equals 0a, negative 2b, b is negative 2. And then when x equals 3, I'll have 3 times 3 is 9 plus 1 is 10, is 2a plus 0b. So a is equal to 5. So I'm going to be looking for, okay, I'm going to just go right back up here and scratch those in. So maybe I'll say minus 2. So when I anti-differentiate this, I'll have 5 logs of the absolute value of x minus 3 minus 2 logs of the absolute value of x minus 1 and a plus c. It's an indefinite integral. That's going to be, what's happening here? 5 and negative 2, right? What's the difference in, okay, yeah. If you had a was you attaching it to the wrong one, so that's harsh. All right, so I'm seeing answer choice D here. Okay. Number 13 is, which of those is the slope field for x squared plus y squared? X squared plus y squared. Oh, this one's interesting. I've never seen this one before. I would love to use that one more regularly. All right, so basically what needs to happen with x squared plus y squared is that this is, I always say start with 0 slopes. When is this equal to 0? This is only equal to 0 when both x and y are 0. Only at the origin. So if I'm looking at these and I'm seeing flat slopes anywhere but the origin, I need to eliminate it. So that's A, C, and D. Okay. B, I see kind of flat slopes, but it looks like really it's getting flatter closer to the origin, and it's going to be, well, x squared plus y squared is positive otherwise. So I can't be seeing any negative slopes either, so that pretty much eliminates, well, A and C. So, but D has too many zero slopes all along the y-axis. This is not how this one's working. So I'm going to be choosing answer choice B. Oh, I may have called C B because it was like on the bottom left, but it's definitely B, like boy. So number 14 is... Okay, yeah. The limit definition of the derivative. Okay, so f of x is equal to 3x squared plus 2x. But also, the definition of the derivative is f prime of x equals, the limit as h approaches 0 of f of x plus h minus f of x divided by h. Now, based on the form alone, I can eliminate answer choices B and D because it's not the limit as x approaches 0. The limit as x approaches 0 could potentially be the derivative of f at x equals 0, but we would need a different form. We would need f of x minus f of 0 divided by x minus 0, and that's not what I'm seeing there. Okay. And besides, they're not even asking for f prime of 0, they're asking for f prime of x. So I'm going to just say f prime of x. Well, maybe I'll just say we can envision throwing this into that formula. I just need to figure out what is f of x plus h. F of x plus h is where I replace x with x plus h in the formula for f. And now, having already eliminated B and D, and just looking at like what happens when I plug in x plus h, well, that's clearly going to be answer choice C. Okay, so 15. So the following is the interval of convergence for the series x plus 2 to the n divided by 2 to the n, from 0 to infinity. It doesn't really matter. So the interval of convergence, well, if you just have done enough of these that you know how this is going to play out, that you can identify the center, I'm going to box it off like that. If you know how to identify the center and the radius and then like kind of mentally think about the endpoints, you can do this one pretty fast. But if you aren't sure, you're going to need to run through the ratio test, which is the limit as n approaches infinity of the absolute value of the ratio of the n plus first term to the nth term. So x plus 2 to the n plus 1 over 2 to the n plus 1 times 2 to the n over x plus 2 to the n. And we're going to absolute value that. Okay, when I go to cancel stuff off, I'll have all but one of the powers of 2 is canceled. And all but one of the x plus 2's is canceling. Okay, so I guess, yeah, sure, is equal to x plus 2 over 2 absolute valued, and I need that to be less than 1. Okay, well, that's going to be negative 1 to 1, negative 2 to 2, negative 4 to 0. And then we need to check the endpoints. Okay, at x equals 0, I have the sum of 2 to the n over 2 to the n, which is 1 plus 1 plus 1, and so on. That does not converge. That was not smart of me, though, right? If I look at the answer choices and I've identified the skeleton, I'm down to just answer choices A and B. And as a result, I am... Well, and if you look at choices A and B, neither of them include x equals 0, so I'm not even going to be considering that. Okay, got a text message. So that was not wise, but I did it, so at least I'm certain. X equals negative 4. I'm going to have negative 2 to the n over 2 to the n. Okay, and sometimes these are the same, right? If n is even, then these will actually be the same. And so this is going to be one of those 1 minus 1 plus 1 minus 1 situations. and that also diverges, so I'm going to conclude it's answer choice A. Right, let's see, how serious is number 6? Oh, number 16, okay. This one's kind of tricky. This one, most people actually do end up getting this one right by process of elimination, but because like there's only one of them that's even like unclear. The rest of them are clearly true because it's asking which statement is false. All right, so am I going to do this? I think I'm going to actually just draw the picture of the graph. Okay, there's a hole in the graph of f at x equals 1 and y equals 0. And then the graph of g pretty much looks like, and then it's filled in here and open over here. And this is x equals 2. All right, the first thing, the limit of f as x approaches 1 is equal to 0. Yes, look, there it is. Both going together. Answer choice B, limit as x approaches 2 of g of x does not exist. That is true, right? We're approaching 2 different values. Okay. Answer choice C is going to end up being the right answer, so I'm going to come back to that at the end. Answer choice D, the limit as x approaches 1 of f of x plus 1, well, that's like the limit of f as x approaches 2. That's pretty clearly existing. You can see on the graph that 2 is like right here, and so it's smooth there. And then times g of x, well, g of x as x approaches 1, that's also existing. That is a true statement, so it can't be the false one, so C has to be the one that's false. But why is C false, right? It looks like it should be true, right? The limit as x approaches 1, I'll write it down, of f of x times g of x plus 1. So this is like the limit of g as x approaches 2, and that fails to exist. So like, what's happening here? What we need to do is we need to consider the limit from the left. From the left, okay, f of x, we're approaching 0 right here. Okay. This is going really close to 0. And g of x plus 1 is staying really steady here at this positive number. And this limit from the left does exist. It's positive. I don't know what it is. It's on the graph. You can look at it. It looks like it might be 1. But either way, this equals 0. But then the limit as x approaches 1 from the positive side of f of x and g of x plus 1. Okay, I'm going to approach from over here, but f of x is still approaching 0, and g of x, that one-sided limit exists, and 0 times a negative number is going to be 0. So I say that both of the one-sided limits exist and agree. And, okay. Number 17. This is a pretty classic no calculator question. This is going to be the integral from 0 to 5 of 5 minus x divided by 5 square rooted dx. Okay, we need to do algebra on this. Like, there's no chance we're just going to be able to think of an antiderivative for this. Not going to work. So I'm going to need to say that this, so 5 minus x divided by 5 is equal to 1/5 of 5 minus x. So I distribute, and I will get 1 minus 1/5 of x. Right, so really what I'm integrating is 0 to 5 of 1 minus 1/5 x to the 1/2 power dx. Now there are kind of two ways you can do this. You can, if you think you can reverse engineer a derivative, which I'm pretty sure I can, we can just kind of attack it directly. And I'll do that in blue. Then I will also do a UDU substitution in red, which works out pretty nicely. So if you don't think that this is going to be realistic for, you know, how you work these problems, then you're probably going to need to use UDU. Okay. So an antiderivative would be 2/3 of this thing to the 3/2. But I'm going to have to adjust for the chain rule right there. Okay. So just to kind of test what would happen if I took the derivative of this, I'd get 1 times this to the 1/2. This is promising. But then I'd have to multiply by negative 1/5. So I probably need to have a negative 5 over 1 there. You can check, and that's a valid antiderivative. And so what I'm going to do is I'm going to just kind of combine this. Negative 10/3 times, okay, let's say, all right, 1 minus 1 is 0 to the 3/2 minus 1 minus 1/5 of 0 is 1 to the 3/2 is going to be 1. And so negative 1 times negative 10/3 is positive 10/3. Okay. Alternatively, you can do a UDU substitution. Okay. And I'm going to let u equal 1 minus 1/5 x, so that du is negative 1/5 of dx. I don't have anything else along with my dx, so I'm going to solve for dx. And that's negative 5 du. And then I need to kind of make a conversion table. I need to go from x's to u's. So when x is equal to 0, u will equal 1. And when x is equal to 5, u will equal 1 minus 1 is 0. All right, so we're going to integrating from 1 to 0, u to the 1/2, dx is negative 5 du. So this is negative 5 times 2/3 of u to the 3/2 is 0 to the 3/2 minus 1 to the 3/2. Again, you're going to get 10/3. How do you want it? You know, you can do it either way. All right. Next one. 18. Which of the following limits are equal to negative 1? Ooh. I asked about this one, but okay. Yes, the graph of this looks like that. Okay, so that is, yes, true. Limit equals negative 1. As x approaches 3, I'm going to factor this thing while I'm at it. That's going to be x minus 4, x minus 3. Over 3 minus x is the negative of x minus 3. So we cancel. And it's the negative of x minus 4. Wait a second. This is not going to be equal to negative 1. It's going to be equal to positive 1, because 3 minus 4 is negative 1, but then I have to divide by negative 1, and that makes it positive. Okay, so no. So I know 1 is and 2 isn't. Sometimes that's enough. No, they have 1 and 3 only as an option. Oh, but number 3 is actually not so bad to figure out, because it's the limit as x approaches infinity of 1 minus x over 1 plus x. These essentially are the same, first degree polynomial on top and bottom. The ratio of the leading coefficients is negative 1 over 1. That one works. It's 1 and 3 only. That's answer choice B. All right. Number 19. Okay, we're going to use the tangent line at x equals pi over 2. So f of x equals 2 cosine x plus 1. So I'm going to need f of pi over 2. F of pi over 2, cosine of pi over 2 is 0, so I've got 0 plus 1. F prime of x is equal to negative 2 times the sine of x. So f prime of pi over 2 is going to be equal to negative 2 times the sine of pi over 2 is negative 2. All right, then I'm going to write an equation for the tangent line. Okay, I've got a point here, x and y, and a slope there. So y minus 1 is negative 2 times x minus pi over 2. What they want you to do is plug in 1.5 to approximate the value of f of 1.5. What we're going to do to make the arithmetic easier on ourselves is we're going to see I got a fraction here. I'm going to make this a fraction and multiply by 2. So I'm going to call it 3/2. So f of 3/2 is going to be approximately equal to, add the 1 to both sides, minus 2 times 3/2 minus pi halves. Right, well, I'm double that, and I'll have 1 minus 3 minus negative pi. So this is pi minus 2, which is answer choice C. All right, next, a particle moves in the xy plane with position x equals log of t plus 1. And y is equal to kt squared. Right? K is a positive constant. The line tangent to the particle's path where t equals 3 has slope 8. Okay, so slope of the tangent line, that's dy dx, at t equals 3 is equal to 8. But I also know that dy dx for a parametric situation is dy dt over dx dt. Okay, so, and then x prime of t is going to be 1 over t plus 1 times the derivative of t plus 1 is just going to be 1, so that's it. And then when I divide y prime by x prime, that's going to kick up to the numerator. So I've got 2kt times t plus 1 equals 8. And maybe I'll show you how that worked. Y prime divided by x prime equals 8, because dy dx equals 8, and dy dx is y prime divided by x prime. All right, but they also were really helpful until it's the t equals 3. So 2 times k times 3 times 4 equals 8. So I'm going to divide by 8, and 3k equals 1, so k is 1/3. And that was answer choice B. All right. All right, now they want me to do a trapezoid sum. I always hate to see that in multiple choice no calculator because that means we actually have to add it all up, and that's going to be kind of annoying, but we'll be all right. Okay, 0 to 2, 2 to 6, and 6 to 10. Okay, so we're going to, the average level, so equals the, we're going to add them all up and divide. Integral from 0 to 10 divided by 10 minus 0. And L of t, if L is the level, something like that. So what I'm going to do is say 1/10, and then my Riemann sum is going to be average the bases and multiply by the width. So the bases are the, I guess really the heights. So 210 plus 200 divided by 2 is 205. Multiplied by the width is 2. Plus, okay, average the levels, whatever they're calling the output, 190 and 200 is 195. Multiplied by the width, 2 to 6 is a width of 4. And then I'm going to average 190 and 180, and that's 185. And I'll multiply by 6 to 10, that's 4. Okay. Ooh. 205 times 2 is 410. Plus, well, this is like 200 times 4, right? And that's 800, except I need to lose 20, so I've got 780. And then 185 times 4, that's going to be 60 less than 800. So that's going to be 740, right? Because I'm 15 off there. I don't know. This is a lot of arithmetic for AP Calculus. This is pretty serious. One of the most intensive I've seen, but it's not impossible. We can do this, right? So, and then if I'm going to take a tenth of it, it's going to be 41 plus 78 plus 74. So I've got 140, 180, 193. Okay, that's answer choice B. Pardon me, that was number 21. 22 is the integration by parts. Okay, and this one I actually really liked because there was kind of a nice quick stopping off point. So x divided by 2 e to the negative 3x over 4 dx. You see a product in the integrand. You see that neither one of the factors of the product is the derivative of the other one, or at least the inside of something. You don't see anything being the derivative of something else. And as a result, we're going to need to use u dv. So I'm going to let u equal, well, I late algebra before exponential, so u needs to be x divided by 2. And dv needs to be the other thing, e to the negative 3x divided by 4 dx. I need an antiderivative for that. And so that's going to be negative 4/3 e to the negative 3/4 x. And now I know that this is equal to uv minus the integral of v du. So uv is x divided by 2 times this is, well, if I divide by 2, I'll have negative 2/3 x times e to the negative 3x over 4. And That's enough to eliminate all of the wrong answers, because there's only one that has negative 2/3. That's answer choice B. So I'm going to move on. Number 23, if f of x is defined by the sum, okay, so x to the 2n over n factorial. Okay, and I want to take the derivative. You can take it by, taking the derivative of the general term and trying to match that up with the general term in the answer choices. Or you can look at the answer choices and realize they all have a unique first term. So all I need to do is take two terms of this, take the derivative, and I'll be able to figure out what's going on here. N equals 1 is x to the 2 divided by 1 factorial. N equals 2 is going to be x to the 4 divided by 2 factorial, which is 2. So f prime is going to be 2x plus, 4 divided by 2 is 2x to the 3. 2x plus 2x to the 3, that's answer choice D. Move on. Okay. I got zoomed out here, but whatever. Okay. Number 24, the average value of a continuous function f. So the average value of f is the integral of f of x dx on negative 2 to 4 divided by 4 minus negative 2. They say the average value is 12, means that the integral from negative 2 to 4 is, I'm going to have to multiply 12 times 6, that's 72. So if they want to know about the integral of f of x divided by 8, that's going to be an eighth of the integral of f, so 72 divided by 8 is 9, and that's answer choice C. Now, number 25, I'll be honest, I feel like there's got to be a better way out there than what I'm about to do. But the Maclaurin series for 2x over 1 plus x squared is closest related. It's, manipulated on the Maclaurin series for 1 over 1 minus x. And that has a radius of convergence of 1, because it goes from negative 1 to 1, because it's a geometric series. And we know that, we do some of these manipulations on the Taylor polynomial, and it's not going to really affect the radius of convergence. And so what you could just say, you think it's going to be 1 because it's related to the other one, and that would actually be valid, and that's going to be the right answer. But if you want to convince yourself of this, we're going to have to take quite a few steps. 1 over 1 minus x equals 1 plus x squared, and so on up to x to the n. 1 over 1 plus x squared is where I replace x with x squared. Really negative x squared, right? Because it would be minus negative x squared. So plus x to the 4 plus plus negative 1 to the n, x squared to the n is x to the 2n. Then 2x over 1 plus x squared is just going to be distributing in a 2x to everything. So the negative positive thing didn't really change. I just multiplied a 2x times x to the 2n. So I think I'm just going to leave it like that. And if we wanted to do the ratio test to determine the radius of convergence, I would be considering the limit as n goes to infinity. Say I'm doing the ratio test here. Limit as n goes to infinity of this n plus first term, but I'm going to take the absolute value of it, and this is multiple choice, so nobody's looking at my work, so I'm just going to not deal with the negative 1 to the n. 2x, that doesn't depend on n, x to the 2n plus, well, if I replaced n with n plus 1, I'd double the 1 also, so I'd have 2n plus 2. And then divided by the original is 2x and x to the 2n. All right, this limit, all but 2 of these cancel. So I'll have an x squared. Absolute value of x squared is less than 1. Well, the absolute value of x squared is x squared. And, well, x squared is less than 1 between negative 1 and 1. That's a radius of 1. I want to move on because I've already spent quite a bit of time on this problem, right? All right, so number 26. This one I thought looked really interesting, and the people that were in my class this morning told me that it actually wasn't that big of a deal, but we'll see. All right, let f be the function with f of 0 equals 1 over pi to the 2. F of 2 is the same. I see what's going on here. And derivative is f prime is x plus 1 times, looks like cosine of pi x, yeah. How many values of x on the open interval 0 to 2 satisfy the conclusion of the mean value theorem? Okay. Well, the conclusion of the mean value theorem is if this function is differentiable, if f is differentiable, which it sure looks like based on the fact that I've written down a nice formula for its derivative, then its average rate of change, its instantaneous rate of change has to be equal to its average rate of change at least once in that interval. And so we're counting how many times does that happen. So, what is the average rate of change? It's rise over run. This didn't rise at all and it ran too. So average rate of change equals 0. So I need just to count the number of times f prime of x equals 0. So it's equal to 0 at x equals -1, but we're not interested in that interval, or in that x value, right? Because it's not between 0 and 2. Cosine of pi x, we do have some zeros on cosine, right? Cosine is 0 here and there. So that's at 1 pi over 2, so that's 1/2. And at 3 pi over 2, so it's where x is equal to 3/2. And at 5 pi over 2 back there, but that's after 2. So this is twice. Those are the places where the instantaneous rate of change equals 0, which means that the instantaneous rate of change equals the average rate of change, which is satisfying the conclusion of the mean value theorem. That's 2 times, that's answer choice C. All right. Number 27 is a nice logistic differential equation situation. dp dt equals 1 over 2,000 times p, so let's call that p over 2,000, times 200 minus p. So whatever this population is, the carrying capacity is 200. Students in a cafeteria. And they tell you the initial condition is 25, so you know that it's less than half the carrying capacity, so you know that that maximum will happen. What is the greatest rate of change in students per second of the number of students in the cafeteria? Okay, well, the greatest rate of change will happen when p equals 100, but that's not going to be the rate of change. I want to just figure out what is dp dt at p equals 100. And that's going to be, well, I plug in 100 times 100 divided by 2,000. 100 times 100 is 10,000. Divided by 2,000 is 5, which is answer choice A. All right. Which of the following is a power series expansion of e to the x plus e to the negative x divided by 2? All right, that's going to be kind of tedious, but I think I can show you in a way that will make sense. E to the x is the easy one. It's 1 plus x squared over 2 factorial plus x to the 3 over 3 factorial, and so on. E to the negative x is equal to, well, I'm just going to replace with x with negative x. But when I take that to an even power, it will just go back to positive. If I add these together, I'm going to get 2, no x's, 2x squared over 2 factorial, no x to the third, and then when I divide by 2, those 2's are going to go away. So I need to see no odd power terms, and everything else being positive. So, and that's going to be answer choice A. All right, number 29 is a related rate situation. Volume is x to the 3 for a cube. They want me to find, oh no, they tell me dv dt is 40. It's increasing at 40. And then when x equals 2, they want dx dt at x equals 2. That's equal to what? Yeah. So I'm going to take the derivative of this implicitly with respect to time. dv dt is 3x squared dx dt. And, well, I'm just going to plug in everything. I got 40 equals 3 times 4 is 12 dx dt. So dx dt is 40 divided by 12, which is going to be 10 over 3. Kind of odd that 10/3 was a correct answer twice in this problem set, but whatever. You don't want to look too deep into that, right? So, which of the following statements about the series 1 over 2 to the n minus n, n runs from 1 to infinity? Okay, which of these is true? It diverges by the nth term test. No, because the limit of these terms is definitely 0. Like, the denominator gets bigger, because 2 to the n is just going to kind of explode. I mean, the negative n is going to get bigger, but the 2 to the n is so much bigger that it doesn't even matter. The limit of the bottom is infinity, so the limit of the terms is 0. So it doesn't diverge by the nth term test, the divergence test. The series diverges by limit comparison to the harmonic series. If we did limit comparison to the harmonic series, we would not have a positive and finite limit. We need to be really comparing with the biggest thing we see, which is 2 to the n. So converges by the nth term test, no series converges by the nth term test. That's the divergence test. That's why I call it the divergence test, is because, you know, can't show a series converges using the divergence test. All right. The series converges by limit comparison to the geometric series 1 over 2 to the n. All right, I'll just show you how that would go. We'll just consider the limit of the ratio of this to 2 to the n over 1. This ratio has limit 1 because the biggest thing on top and bottom is 2 to the n. Okay? And 1 is positive and finite, so they have the same behavior. We know that geometric series converges because it's 1 over 2 to the n. It's geometric with common ratio half, which means that therefore, this thing also had to converge. And that's all 30 of the problems.